Hello there, just a quick video summarising the equations that apply to probability. This is for those people that went to the apprenticeship fair and missed the second lesson that we did on that. So in the lesson before that we talked about these three formula. The first one here we'd used previously. I'm sorry, I'm looking at page 7 of the formula book because they're in the formula book, so we don't have to remember them. So this one here, I think I called this equation 1. We need to use this. This is the way we prove that two events are independent. If two events are independent, the intersection on a Venn diagram is just equal to the probability of one multiplied by the probability of another. If that isn't true, it means that when A happens, B is in some way affected, or when B happens, A is in some way affected. They're not independent. So this is the way we test if two events are independent. If they are, then one probability times the other equals the intersection. So that one is one we have to use, although I'm not sure we need it printed in the formula book. The second one, this one here, I'm not sure we need. So this is the probability of A or B happening, either, the union, is the probability of one added to the probability of another, take away the intersection. And that applies for all events, independent, conditional, that rule applies. But I think we can use common sense to approach that sort of rule. So I'm looking at page 29 in the Stats 2 textbook. I'm going to do a couple of questions there. So the first one we're going to have a look at is question 1. So pause the video at this point, have a go at that first question, see if you can do it without thinking about a formula. Okay, so here's my very poorly drawn Venn diagram. The probability of A and B separately add to 0.9, but the union is 0.6. That means the probabilities inside the circles have to add up to 0.6, which firstly tells me that's 0.4. But how could that be? Well, it must be, as that's 0.9 and that's only 0.6, it must mean 0.3 is in the overlap. So that's what I call common sense. I mean, we can work that out using the formula. I'm not sure we need to. And so that means if the probability of A is 0.4, then that's going to be 0.1. And if the probability of B is 0.5, that's going to be 0.2. So A adds up to 0.4, B adds up to 0.5, the circles add up to 0.6, and obviously everything adds up to 1. So A intersection B is 0.3. Remember, this means the probability of A not happening. So that's everything outside the A circle. So that's 0.6. Union means either. So we're looking at either in the A circle. So let's shade that. Or not in the B circle. So we'll shade everything that's not in the B circle. So we've basically shaded everything apart from that 0.2. So that means that that is 0.8. And I need a different colour for this. So let me just grab a green. So again, another union, so it's either. So not in A, so I'm going to shade everything that's not in A. And in B. So not in A and in B. So either of those two, so I've shaded in everything apart from the 0.1. So the answer of that is 0.9. And question 2 is another one that I'm hoping we can do without having to worry about a formula. So again, just pause the video at this point and have a go at question 2. So another rather dodgy looking Venn diagram. This time we're given the intersection, so the intersection is 0.4. Probability of C is 0.55, so that's got to be 0.15. And D is 0.65, so that's going to be 0.25. So that means altogether there we've got 0.65 plus 0.15, which is 0.8. So that's 0.2 there. And that second formula that I said I don't think we need, that's, if you can do the first part of this question and the first part of this question, you don't need the formula. But let's now use the first formula, because we've got to explain in part C why events C and D are not statistically independent. Remember, that's the first formula, which is if they are independent, the probability of C multiplied by the probability of D would give you the intersection. Now, in this case, the intersection is 0.4. The probability of C happening on its own is 0.55. And the probability of D happening is 0.65. Those two multiplied together do not equal 0.4. So C and D are not independent. You might want to try part B. That's sort of more of the same. I do just want to remind you about the given that notation. It's not part of this sort of formula thing, but so this means that D has happened. Okay, so the answer to B2, the given that bit, D has happened, that gives us our denominator. So D has happened, so that's our denominator, 0.65. Of that, what part of it is down to C? Well, that's 0.4. And these two questions are similar, and it's probably worth having a go at those independently. I would encourage you to try. Okay, let's have a look at the third formula, which is the only one I really think we do need. Okay, so it's this one here, and it's the probability of A intersection B. We know that if they're independent, that's the probability of one multiplied by the probability of another. But if they're not independent, the probability that they both happen together is the probability of one multiplied by the probability of the other, given that the first has happened. And that can be written in two directions. So that can also be written this way around. Probability of B multiplied by the probability of A, given that B has happened. Because, we're not saying that A and B happen in that order. B might happen first. So that formula there can be written in two different ways, with either the probability of A first, followed by the probability of B given A, or the probability of B first, followed by the probability of A given B. And so if you remember, at the end of our the lesson that you were here in, we were just in the middle of this question here, and I think I'd introduced the formula, and I'd asked you to have a go at this question using the formula. So so let's just have a quick look at this one. I'll quickly, without pausing it, throw up another dodgy Venn diagram. We're talking about C and D here. So we know the probability of C is 0.2 and the probability of D is 0.6, and the probability of C given D is 0.3. And what's stopping us filling in this diagram is if we knew the union, like we did in question 1, we could use common sense to draw the diagram. And if we knew the intersection, like we did in question 2, again, we could draw the Venn diagram. But we know neither in this question. But we are given this. And so what I can say is, using that formula and getting it the right way round, I've got this information here. The probability of the overlap is going to be the probability of D multiplied by the probability of C, given that D has happened. Remember, I could write that formula the other way round. Probability of C multiplied by the probability of D, given that C has happened. But I've only got these values here. So the overlap is 0.6 times 0.3, which is 0.18. So now I should be able to answer the rest of the question and fill in the rest of the diagram. So probability of C is 0.2, so this circle needs to add up to 0.2. Probability of D is 0.6, so this circle needs to add up to 0.6. So that's 0.62, so that must be 0.38. Now I reckon we're okay, we can do the rest. So the probability of the intersection, we work that out. Probability of D, given that C has happened. So remember, C has happened, so that's my denominator, the probability of C. Of that, what part is down to D? Well, of the probability of C, 0.18 also involves D. So that's that one. And C union D, that's 0.62. That's just everything in the circles added together. So one final question then, back to page 29 from the textbook, question 6 here. So for one final time, pause the video at that point and just to see if you can have a go at that question 6. Very similar to the one we've just done. Okay, so I've written that formula down both ways round. Why do I know I'm going to need this formula? Well, in the question, I'm not given either the union or the intersection. Give me the union or the intersection, I can draw your Venn diagram without having to think about formulas. And the other giveaway is you're given one of the conditional probabilities, so that tells you it's going to be one of these formulas. So I've written it both ways, but of course I only know B and A given B, so I'm not going to be able to use it that way around, but I can use it that way around. So the probability of B is 0.5, probability of A given B 0.4, so I know the overlap, the intersection, is 0.2. That means that's got to be 0.2, so the probability of A adds up to 0.4. That's got to be 0.3, so the probability of that adds up to 0.5. So the probability of B, given that A has happened, well, A happening is 0.4, probability of that, what part of that also includes B, 0.2, so that's a half, 0.2 out of 0.4. Probability of A not happening, overlapping with B not happening. So where on the diagram will you find A not happening and B not happening? Both of them. So this is A not happening. And switching to blue, this is the probability of B not happening. And I'm looking for places where they're shaded both blue and green. So B not happening is outside the B circle. A not happening is outside the A circle. So the places that are shaded both are the outside the circle. And I did very bad, I didn't work that out, did I? So I've got 0.5, 0.7, so that's 0.3. So that probability there is 0.3. Probability of A not happening, which I shaded green, intersecting with B. So this is B. So green was the A not happening, pencil is B happening. It's the intersection, so it's the overlap between the two, so that's 0.3 as well. Okay, so quick whistle-stop reminder. Yeah, it will be good practice to have a go at those questions on page 29 in the stats book, and a reminder that you've got active teach versions, which are always best, but you've also got the PDF versions. If you're using the PDF version, be careful, we found some mistakes in the answers, so it's always better to use the active teach version because they've got updated answers. Okay, remember the brown envelope papers, you won't be able to do all of those questions because we haven't completed the syllabus yet, but hopefully you can work out with those which you can, and that's a really good way to start getting into general revision. Take care, see you next week.